Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants, and today we'll be discussing empirical formulas. In chemistry, when referring to an empirical formula, we are referring to the simplest version of a molecular formula. And whenever you're looking at the simplest version, you're looking to divide each species by their greatest common factor between them. So in looking at this first example, we have C4H4. Common species between those is 4. So if we were to take this whole value and divide it by 4, we would end up getting the true value, the true empirical formula for C4H4, which is just simply CH. Seems pretty simple. Let's look at the next one. H2O. Note that whenever you do not see a subscript on an atom, it basically means that there is a 1 there. It's implied. So in this case, you really can't divide it by anything other than 1. And any number divided by 1 is itself. So the empirical formula for H2O, water, is simply H2O. Again, fairly simple. It becomes slightly more complicated when you get larger molecules. C6H12O6. Glucose. The only thing that you want to look for is the greatest common factor between them. So in the case of glucose, you can't divide them all by 12, but you could look at 6. 6 divides into 6 and equals 1. 12 divides into 6 and equals 2. So if you took this whole value and you divided it by 6, like so, then you would end up getting an empirical formula of CH2O. And that is the empirical formula for glucose. And that's all there is to it to determine the empirical formula of any given molecular formula. Please note that when dealing with ionic formulas, they are always given in their empirical form because they can dissociate. So whenever you're asked for the empirical formula for something on an exam, chances are it is a molecular compound rather than an ionic compound.